All right, hi guys, here is our second video on polynomial division. So I'm gonna walk through a couple of problems on how we divide polynomials, and this is what we did the Thursday, Friday before break. So if you guys remember, you can use whatever method we did last time. During that class, I taught you guys 3 different methods, and I'm just gonna be using the area box model to do these problems, and that's what I'm gonna model for the rest of the semester. But if you like one of the other ones better, feel free to do that. So I'm just gonna share my screen, and then I'm just gonna walk through some 4 problems with you guys. And then your homework again is just that practice of the complex number dividing and these polynomial dividing, okay? Okay, so here's the first example. What you do is you are going to draw yourself an area model. So I start by just drawing myself a little box. And I know that this side over here has to be whatever I'm dividing by. So this just has to be a box of x plus 2. And then I do a little box on top. And then I just keep extending this as I go, depending on how long it takes me to solve the rest of the problem. First step, we put this x to the 4th in this box right here. And then I'm just gonna create lines in here as I go. And then this is kind of just like a puzzle. You're trying to figure out what you are gonna multiply this x by over here so that you get that x to the 4th. And so I know if I do x times x cubed, I get x to the 4th, so that becomes x cubed on top. And then I can solve the box down here because this becomes 2 times x cubed, which becomes 2x cubed. And now what you do is you just have to look at the problem itself. So I need my final answer to have a total of 9x cubes, positive 9x cubes. So you just have to think about what do you add to 2x cubed to make it become 9x cubed? Well, 2 plus 7 is 9, so this has to be 7x cubed. And your diagonals are always going to be your like terms. Okay, so then I draw myself another box. And then I just have to fill in the missing spaces. So I know that this top box has to be 7x squared, so that when I do 7x times x, I get the 7x cubed. And then this box down here has to be 14x squared. Okay, then I do the same thing. So I just think about, all right, I have 8x squared. So what am I gonna do to 14x squared to get it to become a positive 8x squared? Well, I can subtract 6x squared. So then that's what goes in the box there. All right, then we just continue. So let's see, this has to be a negative 6x, so that when I do that times x, I get 6x squared. This has to be a negative 12x. And then I need it to add to be a negative 17x. So if I take away 5 more from that, that becomes 17. So that will be negative 5x there. Create another box, and then this just has to keep extending just a little bit. Okay, so then up here, this has to be a negative 5. And then if I do negative 5 times 2, this becomes negative 10. And now at the very end, this was a negative 10. And since that's what I got down here, that means that we have no remainder. And what you just did is you took this x to the 4th plus 9x cubed plus 8x squared minus 17x minus 10, divided it by x plus 2. And your final answer is going to be, let me change colors here, is going to be what you have on the top up here. So your final answer to this is going to be x cubed plus 7x squared minus 6x minus 5, and you don't have a remainder. So then that's what you're going to end with. Okay, so let's do it one more time. You guys kind of got the hang of this. You could probably pause because this one's going to be really similar. Try it yourself and then just check and see if you get the same answer as me. Okay, so we're going to set it up the same way. Put whatever you're dividing by on this side. Give myself a little space on top. This 4x squared has to go, or cubed has to go in the top box here. And then I just figure out what makes it work. So let's see, this has to be a 4x squared. So when I do that times x, I get 4x cubed. Then if I do 4x squared times negative 1, this becomes negative 4x squared. Then I think about my diagonal. Okay, so I need this to be a negative 2x squared at the end of it. So I can add a positive 2x squared to this one. Okay, that means this top box up here has to be 2x. This has to be a negative 2x. And then diagonals here, I need that to be a positive x when I add those together. So what can I add to negative 2x to be a positive x? That could be a 3x. Then I know the top up here has to be a 3. So when I do 3 times x, I get 3x. And then if this box is negative 3, and those match up, I again know that there is no remainder. So when I take 4x cubed minus 2x squared plus x minus 3, divide by x minus 1. I get a final answer. Remember, your final answer is going to be whatever you have on top up here. So my final answer would become 4x squared plus 2x plus 3. Okay. Now these next two have a remainder. So I want to do a little bit of going backwards in our learning. And talk about how we deal with remainders when they're with real numbers. So I want to do 29 divided by 4. Okay, so our first thought process is, what do we multiply, or how many times does 4 go into 29? Well, I know that 4 times 7 becomes 28, and that's the most that it can go in. So I put the 7 on top. Then I do 7 times 4, which becomes 28, and I put it here. Then we subtract, and then there's 1 left over. So the way we write this answer is that 29 divided by 4 becomes 7 is your whole number, your remainder is 1, and then you divide it by whatever you were dividing by. So it becomes 7 1/4. And we're going to do the same thing with our polynomials. Okay, so we set this up the same way. Create yourself a box. So what we're dividing by, let me make this, goes on this side. So this becomes 2x plus 10. And then I'm going to put this first term in this top box, so 2x cubed. And then I'm just going to create a little line. All right, so what do I need to multiply 2x by to get it to become 2x cubed? Well, that has to be x squared. And then if I do x squared times 10, this becomes 10x squared. All right, this one's really mean because do you notice that in this equation there isn't an x squared? So really what that means is we have 0 x squareds left. So what we have to do is we have to make this diagonal become 0 so that it disappears. So I'm going to make this a negative 10x squared so that when I add those together, they cancel out. And then the top of my box up here would become, let's see, what do we multiply 2x by to get it to become negative 10x squared? This would have to be a negative 5x. And then negative 5x times 10 becomes negative 50x. And then what you're trying to do is you're trying to get your x's to be negative 60. So what do I have to do to negative 50 to get to be negative 60? I subtract 10 x's, and then just extend. Okay, so let's see, what do we multiply 2x by to get it to be negative 10x? Well, this has to be a negative 5. And then 10 times negative 5, this is negative 50. Now in this one, we didn't get the final answer to match our equation. So we didn't get negative 44, we got negative 50. So we have to find a way, ooh, that was a really bad highlighter. Let's make it a different color. So we have to think about, what do you do to make negative 50 become negative 44? Well, if I add 6 to negative 50, that makes it become 44. So whatever you have to do becomes your remainder. So in this case, I have a remainder of 6 left over. So this division problem, remember your original answer is on top up here. And then we have a remainder of 6. And we're going to write it the same way we did with that other one. So we have this 2x cubed minus 60x minus 44 over this 2x plus 10 equals x squared minus 5x minus 5. And then our remainder, we're writing it the same way that we did right here. So you have whatever you got as your remainder, which was 6. So we put plus 6. And then our denominator is what we were dividing by. So in this case, it's 2x plus 10. And then that is going to be your final answer. Okay, so let's do the last one. You guys go ahead and feel free to try to do this one on your own and then check your answer with me. Okay, so let's set up our box. So you do x plus 2, what you're dividing by on this side. We put the highest term in this box right here. And then we just work our way through the puzzle. So what do we multiply x by to get to become 3x to the 4th? Well, this has to be 3x cubed. Okay, then I do 3x cubed times 2. That becomes 6x cubed. Diagonals have to equal whatever my cubes are. So if I have 6x cubed, I need it to be 7x cubed. That means this is going to be a 1x cubed. Okay, so let's see, 1x cubed, I already have an x, so this has to be an x squared. Then if I multiply 2 times x squared, this becomes 2x squared. Then I think about my diagonals again. I need my x squareds to become 3x's, so this has to be a 1x squared. I know in the top up here, this has to just be an x because x times x gives us x squared, and then 2 times x is x. We're just going to extend it one more. All right, then I need my x's to be a -1. So if I'm at 2, I'm going to subtract 3x from it. So then x times -3 will give us a -3x, and then this is -6. Again, our numbers at the very end do not match. So that means that we have a remainder. So what you tell yourself is, what do you have to do to -6 to make it become a -4? Well, if I add 2, I get it to become a -4. So the remainder of this problem is 2. Okay, and then remember that your final answer to this is just the top part of your box. So whenever I take these two things and divide them, the final answer to this is going to be 3x cubed plus x squared plus x minus 3. You have a positive remainder, so plus 2 over, and then what I was dividing by was x plus 2. So then that's going to be your final answer. Okay? I hope that makes sense. I want you guys to now go try to do the practice problems of dividing complex numbers and polynomials, and then I will reach out and let you guys know when our next class meeting is so that you guys can ask questions and get help on whatever you are confused on. But please feel free to email me at any point in time if you're confused or need help with anything, okay? All right, well, I look forward to seeing you guys later. Bye.